Yes, hello friends, welcome to the session. Continuation of chapter 7 DC to DC converters. Still now I discussed about what exactly buck regulator and boost regulator, that is step down chopper and step up chopper. The another important converter, important for any competitive point of view, that you concentrate on buck boost regulator, that is up down chopper. Buck boost regulator. Yes. Buck boost regulator. Then it is up down chopper. It is also called V2I and I2V converter. Okay. First you draw what is the circuit of buck boost regulator or up down chopper. I told already how to identify buck boost regulator. Inductor is at middle. This is load. Okay, parallelly draw the circuit, don't wait. This I0, positive negative V0, this capacitor, this is chopper or switch. This diode, positive, negative. L, and this current is IL. This current is IC. Yes. But you know that one operation is nothing but a one on and one off. First one is chopper on. Chopper or switch is on. Then what about the diode is under off state? Then what the equivalent circuit? Inductor, VDC, plus minus VL. This is IL. Diode is half state. This capacitance. This load. This IC, I0. Okay. Can you apply KVL? Then VL equal to VDC. What about KCL? At this node, both are leaving. IC plus I0 equal to 0. Then IC equal to minus I0. VL equal to VDC. But one operation is nothing but one on and one off. Chopper is off. Then what about the diode? Chopper is off means diode is on. Same procedure I am following, no need of any confusion. All the circuits are analyzing with the same concept only. That's why no need of any confusion. Even you forget any formula, then you can derive by your own applying the concept. Understood? Okay. Then chopper is off, diode is on. Then what is the equivalent? This VDC plus minus this IL. Diode is on. Positive, negative VL. In this case, inductor storing the energy. Here inductor storing the energy. Storing the energy. Here inductor releasing the energy. Inductor releasing the energy. Releasing the energy. Okay. Then this is diode, capacitor, load. Positive, negative V naught. This I naught, this IC. Then apply KVL. What you get? KVL is V naught equal to, that is V naught minus VL equal to 0. Then VL equal to V naught. What about KCL? This IL is here. This is IC. This is I. IL plus IC plus I naught equal to 0. What is IL equal to? Minus of IC plus I naught. Yes, this is KVL and KCL. Then first one is volt second balance. Volt second balance. What the volt second balance means? Under volt second balance, VL into VL on into T on plus VL off into T off is equal to 0. What is on state voltage? VDC. What is the VDC into T on plus what is off state voltage? V naught into T off is equal to 0. Shall you write like this? V naught equal to minus VDC into T on by T off. Then what is V naught, you tell me? V naught equal to minus VDC into, how to write T on? T on is dt. How to write T off? 1 minus d into T. Then what is V naught equal to minus VDC minus d into VDC by 1 minus d. And this is average output voltage. Minus d into VDC by 1 minus d. But why you are getting negative sign here? This important consideration. See, in all the previous cases, always whatever the inductor current is there, that inductor, you take the buck regulator or boost regulator, the inductor current is enter here. But here, whatever the inductor current is there, in the case of buck boost regulator, this is the flow of inductor current opposite to load current. That's the reason why we are getting negative sign. But in the calculations, don't take any negative sign. The reason for negative sign is, yes, inductor current is opposite to load current. But in the boost regulator and buck regulator, the inductor current is always in the direction of load current. Okay. But in some cases, in order to, you don't get any negative sign, they will change the polarity. You take minus plus, then you don't get any negative sign during derivation. But in the problem is framing, it will mention that this is minus, this is plus in buck boost regulator. In most of the problems, in the problems they will give minus plus. Why they will giving minus plus means in order to eliminate that negative sign. But as it is with the same polarity I am deriving, because in the previous cases also I taken plus minus now. That's why I taken here plus minus also. But I get negative sign. But don't bother about negative sign. The reason for negative sign is because what is the reason for negative sign? Because IL is opposite to I0. Opposite to I0. That's the reason why you are getting negative sign. The inductor current is opposite to load current. But in the previous cases, always in the same direction. Okay. Then generally you take what the average output voltage, D into VDC by 1 minus D. You take only absolute value. No need of considering any negative sign. This is exact formula. This is average output voltage. That means V0 equal D into VDC by 1 minus D means for 0 less than D less than 0.5, V0 less than VDC. In this, you substitute for duty cycle for 0 to 0.5, we can get V0 less than VDC. Then it acts as a, which one? Step down chopper or buck converter. Step down chopper or buck regulator. For 0.5 less than D less than 1, we can get V0 greater than VDC. Then it is a step up chopper. Step up chopper. That's why it is a up down chopper. That's why it is a up down chopper. But for D equal to 0.5, we don't have any step up and we don't have any step down. We get V0 equal to VDC. That's why for 0 to 0.5 duty cycle, it acts as, you substitute any value in between 0 to 0.5, we can get V0 less than VDC. You substitute any value 0.5 to 1, then you can get V0 greater than VDC. Then it's a step up. For D equal to 0.5, you don't have any step up and step down, then we can get V0 equal to VDC. That's why this is step down operation, this is step up operation. That's why it is a up down chopper or buck boost regulator. Understood? Once you know the average output voltage, this is average output voltage. And this is the average output voltage of buck boost regulator. Once you know the average output voltage, then what is average load current? I0 equal to V0 by R if it is R comma RL load. Then I0 equal to V0 minus E by R if it is RE comma RLE loads. Okay, one is over. One parameter is completed. That you are calculated average output voltage and average load currents. Then go for second one. But point to remember here, whatever the waveforms are there, the waveforms of buck boost regulator is similar to that of boost regulator. There is no change. There is no any change. The waveforms of buck boost regulator is same that of the boost regulator. Even the current through the capacitor waveform is also similar to that of boost regulator. Here I am not drawing any waveform again. The waveforms of the buck boost regulator is same that of the boost regulator. Even IC current waveform is also same. Why I am telling that IC current waveform is also same means if the chopper is on state, diode is off. Once the diode is off, capacitor acts as a short circuit. Capacitor is capacitor is supplying the current to the load. That's why the voltage across the load is nothing but a voltage across the capacitor. Okay, that's why during chopper is on state, capacitor will supplying the current means then what is IC equal to? We can get minus I naught. Okay, same waveform we can get. There is no change. That's why the waveforms of the buck boost regulator is similar to that of the boost regulator. That is, no need to draw again. If you want to, that means that same waveforms again you redraw. Clear? Okay. Then I naught equal to V naught minus E by R, that is RE comma RLE load. Then ampere second balance. Second one is ampere second balance. Ampere second balance. What is the ampere second balance? IC on into T on plus IC off into T off is equal to 0. What is IC on? IC on is minus I naught into T on. What is IC off? Minus off. From this one, what is IC off you want now? Minus off IL plus I naught. IL plus I naught into T off is equal to 0. Shall you write like this? Minus I naught into T on is equal to IL plus I naught into T off. Yes? How to write this? You want expression for I naught na? You want expression for I naught. Shall you write like this? Minus I naught is common. T on minus T off is equal to IL into T off. Then minus I naught into what is T on dt? What is T off? 1 minus D into T. Or otherwise, you write like this. Okay. Minus I naught into T on by T off minus 1 is equal to IL. That is minus I naught into dt by 1 minus D into T minus 1 is equal to IL. Okay. Then you simplify this. What do you get? You tell me. We are getting IC equal to minus I naught. IC equal to minus of IL plus I naught. This minus I naught into T on. This IL plus I naught into T on. This minus I naught into T on. Yes, see here you can take plus na. You take minus I naught is common. Plus. Then what you get? You tell me. TT cancel. Then minus I naught by 1 minus D you can get. This is IL. Therefore, IL equal to minus I naught by 1 minus D. This is correct. Okay. Here I am bringing this side minus common means T on plus T off you can get. Then the negative sign, the reason you know. What is the negative sign? Because inductor current is opposite to load current. But you take the positive only. Therefore, what is the average value of inductor current? IL equal to IL average. This is how much? I naught by 1 minus T. It is similar to that of what you derived in the case of boost regulator. Okay. Note down this. Don't confuse with negative sign. No need to consider this negative sign. The reason you know. But generally take the magnitude only. Then you take I naught by 1 minus T. The second parameter is completed. Then what is the third one? What is the average value of switch current? How to calculate average switch current? Same concept. that I told. To calculate average value of, to calculate average source current for lossless chopper, okay, for lossless chopper, what is the condition? Input power equal to output power. What is the input power? Vs, that is VDC into Is, is equal to V0 into I0. Okay, then VDC into Is equal to, what is V0? You write V0 is VDC by dVDC by 1 minus d into I0. VDC cancel. What is Is equal to d I0 by 1 minus d. This is average source current. Average source current. The average source current. Then fourth parameter. How to calculate peak to peak inductor ripple current. Peak to peak inductor ripple current. Peak to peak inductor ripple current. Inductor ripple current. How to calculate? You take either T on or T off during T on. During T on means VL equal to L into di by dt. That is L into delta IL by T on. What is voltage across inductor during on state? VL equal to VDC. VDC equal to L into delta IL by T on. Then from this, what is delta IL equal to? VDC into T on by L. T on is dt, that is dVDC by FL. I written T on is dt. If you write T on is dt, T is written as 1 by F. Then delta L equal to dVDC by FL. Then it is maximum at D equal to 1. Then what is delta IL max? Delta IL max equal to D by FL. Sorry, VDC by FL, because D equal to 1. VDC by FL. Then this is fourth one. Then what about the fifth one? Okay, this over na? Yes, parallelly note down. What about IL max? IL max equal to IL plus delta IL by 2. What about IL minima? IL minima equal to IL minus delta IL by 2. Sixth one. Can you tell what is the average value of switch current? ISW average. Same formula we are getting. The average switch current. Switch also supplies which current? Inductor current only. Then average switch current equal to during which time? On state. D into IL. What is the RMS switch current? RMS switch current equal to RMS switch current equal to root D IL. root d IL. What the peak value of switch current equal to? IL max. Peak switch current equal to IL max. Can you tell what the peak voltage across the switch? When the peak voltage will appear across the switch during off state? I give an equivalent circuit during off state now. You see that circuit. Then what is the peak voltage across the switch? The switch voltage is nothing but a inductance voltage. Is VL. Peak voltage across the switch. VL plus VDC. Yes, this is the equivalent circuit now. During off state. This is inductor. This is VDC. Then these two will be added. The peak voltage across the switch. Peak voltage you want means you reverse this polarity. Then this is VL, aiding polarity you can get. This minus plus you take during discharging. But in the KVL you are taken as it is. But here you want peak value now. That's why you can take minus plus. This is minus plus. Aiding. VL plus VDC you can get. This is a peak voltage across the switch. Peak voltage across the switch is VL plus VDC. Then what about the average value of diode current? ID average. IL into 1 minus D. What the RMS value of diode current? IL into square root of 1 minus D. Same formulas. Okay, diode is conducting during which state? Off state. Same formula you can get. IL into 1 minus D. That is IL into square root of 1 minus D. Next. 8th one. Peak to peak capacitor ripple voltage. Peak to peak capacitor ripple voltage. Capacitor ripple voltage. Peak to peak capacitor ripple voltage. In a peak to peak capacitor ripple voltage, how we can calculate? Q equal to C into Vc, then Q equal to, then delta Q equal to C into delta Vc. Then what we get? Then delta Vc equal to delta Q by C. What is the delta Q? The waveform is, that is IC waveform is, IC waveform. I am not drawing. IC waveform is similar to boost converter. Similar to boost converter. Boost converter. Because during on state capacitor will supplying the current to the load. Okay. Then what is delta Vc? Delta Q is area under the current curve. What you are calculated? I naught into T on by C. Then what you get? D I naught by FC you can get. This is the peak to peak capacitor ripple voltage. Then it is maximum at D equal to 1. It is maximum at D equal to 1. Then what is delta Vc max? Delta Vc max equal to, because maximal duty is 1 only. That's why directly no need to differentiate here. I naught by Fc. Correct. Then 9th one. Critical inductance. Critical inductance. How to calculate critical inductance? The critical inductance, LC, calculation of critical inductance. What is the concept we can apply? IL minima equal to 0. IL minima equal to 0. What is IL minima here? IL minima, IL minus delta IL by 2 equal to 0. Then what is IL equal to delta IL by 2? What is IL? I naught by 1 minus D. You take only magnitude. Don't consider negative sign. The reason that you know negative sign. I naught by 1 minus 2. What is delta L? dVdC by FL. That is 2FL. dVdC by FL. That is 2FL. What is I naught? V naught by R into 1 minus D. This equal to, that is V naught by R into 1 minus D. dVdC by 2FL. Correct. What is V naught? dVdC by 1 minus D. That is D into VDC by 1 minus D, R into 1 minus D whole square. This equal to dVdC by 2FL. VDC cancel. Then from this, what is L equal to? This is LC. This inductance is treated as a critical inductance because we are calculating This inductance is calculated by making IL minima equal to 0. That's why it is treated as a critical inductance. Then what is LC equal to? R into 1 minus D whole square by 2F. This is the critical inductance for buck boost regulator. Okay, this is 9th parameter. Then last one, 10th one, we want to calculate what is the critical capacitance you want to calculate. First note down this quick. Over. Then what is the 10th parameter? Can you try this one? How to calculate critical capacitance? You know the procedure how to calculate critical capacitance. This is the 10th one. 10th parameter. Critical capacitance CC. All these procedures I given already. Critical capacitance CC. Then how to calculate critical capacitance? Delta VC minima equal to 0. What is the delta VC minima? That is V0 minus delta VC by 2 equal to 0. V0 equal to delta VC by 2. What is V0? dVdC by 1 minus D. What is delta VC? Delta VC calculated na? D by, what is delta VC calculated? dI0 by FC. dI0 by FC. Then dV0 by R into FC. Then dVdC by 1 minus D equal to D by R into FC. V0 is written as dVdC by 1 minus D. Okay. And from this dVdC by 1 minus D, dVdC by 1 minus D is cancelled. Then what is critical capacitance? CC equal to D by, this is 2 na, this is 2, this is 2, D by 2FR. The critical capacitance CC equal to D by 2FR. This dVdC by 1 minus D. This is V0 equal delta VC by 2. That is dI0 by FC, dV0 by 2FC. V0 is nothing but VDC by 1 minus D. This is cancel. This is cancel. Then from this C equal to, what you get? C equal D by 2FR. This capacitance is nothing but a critical capacitance. Okay. Okay, these are the different parameters we are calculating in a buck boost regulator or up-down chopper. Okay. This is analysis of buck boost regulator or step-down chopper in the case of continuous mode. But I want to write one formula in discontinuous mode. You know the procedure how to calculate average output voltage in a discontinuous mode. Okay, apply that quick. Do this. That is average output voltage in discontinuous mode. That is buck boost regulator in discontinuous mode. Buck boost regulator in discontinuous mode. How to analyze buck boost regulator in discontinuous mode. Okay. You know that in discontinuous mode means before completing one half cycle, current falls to 0. This is dt, beta t, t. For this current IL max, IL minima equal to 0. Okay, this IL current waveform. Okay, then can you tell how to write this one? Here delta IL equal to IL max because IL minima equal to 0. What is IL max? That you know. Then to derive the V0 formula, go for volt second balance. For the volt second balance, VL into VL on into T on plus VL off into T off is equal to 0. Then what is the voltage across inductor during on state? VDC. VDC into T on. What is the voltage across inductor during off state that you derived? V0. What is the off state? Beta. What is the T off time? This is on time. This is off time. How to calculate that you know? This total is beta T. This is dt. Then what is T off equal to? Beta T minus dt. That is beta minus d into T. This only changes. As compared to continuous mode and discontinuous mode, only off time it changes. You replace that off time by instead of 1 minus d into T, beta minus d into T, remaining analysis, any parameter we can calculate under discontinuous mode. But I am calculating only average voltage. But if you want any parameter, means replace off time by beta minus d into T. Then you can get any expression. Then V0 into beta minus d into T is equal to 0. Then minus VDC into T on is equal to V0 into beta minus d into T. Then how to write T on equal to dt? T on is dt minus VDC into minus VDC into T on is dt is equal to V0 into beta minus d into T. Then TT cancel. What is V0 equal to? Tell. What is V0 equal to? Minus d into VDC by beta minus d. But that negative sign is because of IL is opposite to I0. IL is opposite to I0. But you take only positive. Then what is the voltage across? Average output voltage dVdC by beta minus d. You substitute beta equal to 1, you get same that of the without same that of the continuous mode. In this case, you substitute beta equal to 1. You substitute beta equal to 1 means then we can get same that of the continuous mode of operation. For beta equal to 1, that is same that of continuous mode. And the waveforms note I am giving. Waveforms in buck boost regulator. I am not drawing any waveforms. Buck boost regulator. Same that of boost regulator. That you concentrate. The waveforms in buck boost regulator is same that of the boost regulator. Okay, this about the analysis of buck boost regulator or up-down chopper. Buck boost regulator or up-down chopper. One observation here. Here negative sign means negative sign. That means in the case of boost regulator, we are not getting any negative sign. In the case of buck regulator, we are not getting any negative sign. That's why only in buck boost regulator only negative sign we are getting. Okay, the reason is inductor current is opposite to the load current. That point. But in the substituting the values, no need to take the negative sign. If it is given negative sign, then you take. But maximum in the framing of the problems based on this buck boost regulator, at the starting in the circuit, they will give instead of plus minus, they will give the minus plus output voltage. But I derived all these formulas by assuming that plus minus. But maximum in the problem they are mentioning minus plus only. Okay, that you concentrate. Okay, clear? Okay, concentrate. In the next session, I will continue with what is the analysis of buck boost regulator under practical case. Practical case means in this I am not considering any internal resistance of inductor. If you consider the internal resistance of inductor, what is analysis, then I will give the summary also. Okay, with that buck boost regulator will be completed. Then those are the types of choppers or types of regulators, DC to DC regulators based on the output voltage level. After discussing that, then we go for the what are the types of choppers based on the quadrant operation. Okay, the next session we will continue with what is the expression for average output voltage of buck boost regulator as a function of internal resistance of inductor. As a function of it. Here also one point to remember. In the ideal case, what is the average? In the continuous mode, what is the average output voltage we are getting? In the continuous mode, V0 equal to dVdC by 1 minus d. If d equal to 1, what is V0 you can get? Infinity. But that is only ideal case. But practically V0 is 0 here also. For d equal to 1, even in the buck boost regulator also, the average output voltage is 0. It is not infinity. Why the average output voltage 0? Because during on state, for d equal to 1 means T on equal to T. T on equal to T means switch is completely on. During on state, switch is on state, then inductor will supplying, inductor is charging. Imagine that equivalent circuit what I given. Inductor is charging. Once during inductor is charging, capacitor will supplying the current to the load. That means capacitor will act as a short circuit. Capacitor will act as a short circuit means the voltage across the load is 0. That is also unstable operation. That's why in buck boost regulator also for d equal to 1, it is unstable operation. Then practically for d equal to 1, what is V0? 0. Understood? That I will give the proof also practical by considering the practical condition. Okay. Yes. In the next session we will continue with another expression based on buck boost regulator. Okay. Thank you.